Now we're recording. All right. The most difficult thing with these is the bigger the numbers get, the more of a pain in the butt it is because you've got to go further into your perfect square chart. If your perfect square chart only goes to 11 or only to 15 and it gets upwards in the 300s and 400s, yeah, it's going to be a pain in the butt. 111 is not bad because it still falls in your perfect square chart. Does anybody know what two perfect squares that 111 falls between?
120.
120 is almost a perfect square. It's very close. What's the smaller perfect square? Yeah. 100. It falls between the perfect square of 100 and what's the other one? Is it 121? Okay. Now, with your perfect square charts, what are those two perfect squares? What's the square root of 100? Shout it out. People on here can't hear. They're like, what's wrong with the class? They're very quiet. It's 10. The square root of 100 is 10. The square root of 121 is 11. Okay? So far, so good? So far, it's not hideous. Now, would it be wrong if you would have put the perfect square of 120 instead of 121 when you're estimating, but you still had the square root of 120 as 11? Would that be okay? But it just be a clerical and numerical error. You had the right parameters. There may be a question on the test that'll say, which two numbers does this square root fall between? They may say it in a different way than that, but that's all you have to do is find out what two perfect squares that it falls between. Now, we're not done yet. We're not done yet. We have to figure out. Now, I do this. You may not do this. I like to make that goofy number line. And over here is going to be 10, because that's our one perfect square. And over here is the 11, that's our other. I like to find the dead center middle between the two. What's between 10 and 11? 10.5, good. So we've got to figure out, is my estimate for the square root of 111 bigger than 10.5, smaller than 10.5, or pretty spot on 10.5 right in the middle? Well, let's see. I think this one's not that horrible. How far away is 100 from 111? It's 11 away, right? How far away from 121 is 111? Holy crap, those two numbers are really, really close. Now, for my estimate for this, if I'm looking at it, if I put 10.5, am I wrong? No. No, that's pretty spot on. I mean, it's just a smidge closer to 11, isn't it? Just, a little bit. So, it should be anything in there. Anything in there would be good. I would probably say my best estimate for this one would be about 10.5. Don't forget the approximation sign. Do not forget about 10.5. Because if you just put 10.5, no, it's not. It is around 10.5. It is about, what if you put about 10.6? Still good. About 10.7. Still good. A little further away, but it's not bad. What if you said, you know what, I think it's about 10.4. I probably am not going to bust 10. Okay, it is just a little closer to 11, so it should fall in that area over there. But when you've got that dead center middle one, there's a wide array of answers that you could give. Is this making sense? Okay, these should not be any issue. There's a problem on the test that deals with the estimated square root. I give you 4 to practice on this worksheet. I did 111. Do square root of 22. If you haven't done square root of 22 yet, do the square root of 22. Use your chart, go through it, figure out which two it's between. Does it round up, or does it say, is it a little larger midway point, a little smaller midway point? I'm going to put it up on the board. We'll do one more, but then we're going to start doing the review of this entire chapter. I love perfect square roots. Love it. It's like higher level math for sure. Algebra 2. Square root of 22. Some of you already have that one done. And if you do, good. Get square root of 60 and the square root of 94 done. Some of you already have all 4 of those done. Awesome. Flip over and start working on the other side. Don't wait for me to study. If you understand this correct, get it done. Then you can utilize the second half of this hour for your other classes. Because the bad news is, I shouldn't say the bad news, you guys are still going with like full class loads of homework today. You're doing 1st through 7th periods. We don't start that just 1 through 4 until next week. So you'll want to, when I stop being obnoxious and talking, you'll probably be given a good half hour, 40 minutes to just sit and work on another class's work. I lied to you before when I said that this would take all the way to the second step. I would not punish you like that on it. Because you guys are still getting all your classes' homework today, right? All 7 periods. That's why we're going to this 1 through 4 kind of a deal. Just to lessen the amount of homework that you're getting from teachers. Math hasn't been too bad, has it? Homework-wise? If you've been staying up on it, just let me know if it gets to a point where it's like, oh my gosh, I can't keep up. Because I don't want you to feel that way right now. It's fun for me, but it would be mean. Hi. Okay, that we're going to talk about that. This is not asking you to do any work. This is just asking is it rational or irrational. Yep, we're not there yet. That's level 3. We're just going to good. Ask that in about 5 minutes. All right. What 2 perfect squares does 22 fall between? You're ahead of us. You're telling me the answers to the perfect squares. 16 and 25? Is it wrong that you said 4 and 5? No, you're right. 4 and 5 are the 2 perfect square solutions. It's the square root of 16 and the square root of 25. You're one step ahead. If you don't need to sit here and write out the square root of 16 and the square root of 20, don't do it. Just go to the perfect squares that you know. It's the square root of 16 is 4, the square root of 25 is 5. Okay? I just do this because I'm old and I want to go through the steps and make sure everybody's all honky-dory. It's between 4 and 5, and the dead center middle between 4 and 5 is 4.5. So, will our answer, just by looking at the numbers that we've been given so far, will our estimate fall on the upper half of 4.5 or the lower half of 4.5? I think it's going to be an upper half. Let's test. How far from 16 is 22? It's 6. How far from 25 is 22? Yes, it is closer to the bigger number, so it would have to fall in the upper half. So anything in there is going to be good. So approximately my guesstimate would be 4.7, 4.8, anywhere there. Guess what? What if you put 4.6? Great. 4.5. It's okay. Below 4.5, we have an issue. If you're just guesstimating without doing any kind of the looking and seeing how far between, you may get some wrong guesstimates, but it's not horribly wrong. It's just mostly right-ish, wrongish. It's right in the middle. Okay? Anything between 4.5 and 4.9 is beautiful in this problem. 4.9, fine, as long as it's estimating. Does this make sense? Ding! Turn the page. Flip it over to the front side. Now, we are going to begin going through step by step, inch by inch, this whole worksheet, a little bit and a little piece from each part. Okay, this review worksheet right here. All right. Look at the first 4 sentences. A little more in depth than what you're going to be required. This is like a chapter review-ish, things that you need to know how to do. I can convert a repeating and terminating decimal into a fraction. You should be able to, but just a single digit repeating. If you want to write that above this part, it is. It's just a single digit repeating decimal. Okay, nothing more than that for this first test that we're going to take. I can convert a single digit repeating decimal. Second part, I can identify if a number is rational or irrational and explain why. Huge. If you want to put a star next to that sentence, That is the make or break of this test. I'm letting you know right now. Sentence number 2 is the make or break of this test because question number 1 on the test is 5 parts. And it is all, is it rational or irrational? That's 1 point. And then why is it rational or irrational? That's the second point. Okay? So you've got to know the reasoning, and we're going to go over that. That's on here. We're going to go over that. If you want to get at the very worst a 2 on this test, which that's the very best you can get on this test, if you want to lock down a 2, get that part right about rational and irrational, and everything else will be a take 1 for you. Okay? And we're going to go over it, so don't freak out. Sentence number 3. I can estimate square roots to the tenths and the hundredths place. Cross out the hundredths place. You do not need to estimate to the hundredths. We aren't there yet. I say yet because that means we're not there yet. All right? So we're only doing to the tenths for estimating square roots. And I can compare the numbers in different forms. Decimal fractions, radicals, yada, yada, yada. Put a later next to that bottom. That last sentence, it's later. You're not going to need to compare and order those numbers yet. Okay? You need to know how to take it. We've done it, honestly. We've already started to find the square roots of numbers and put them in order and convert decimals into fractions and convert fractions into decimals, all this kind of stuff. Eventually, not right now, but eventually you're going to need to know how to put them in order from smallest to largest. And we'll talk about it. I don't want to fill your brain with clutter right now. Number 1. Write each as a fraction and simplify. Okay? Any number 1, no repeating decimals in any of these. The biggest thing that you've got to be able to do is read the decimal and know their place value. That's all you need to do. So, Jimmy James, choose any one of numbers from number 1. Any one of those 4 decimals. I don't care which one you want to choose. Choose one, and we'll go over it right now. Ooh, good one. The one that says 0.45. 0.45. And you want to be able to convert that into a fraction. It's good that you know 0.45, but you want to know right now, read the number like there's no decimal. How do you read that number? 45 tenths hundredths. 45 tenths hundredths. 45 hundredths. That's all it is. Know the place value of the last digit, and just put that number as the denominator, as the bottom number. That's all these are. If I put a 1 out in front of it, guess what that 1 means? Squat. Means nothing. I don't need to worry about it. Throw it aside, just put it into the answer. Okay, I could add any amount of digits and negative signs or whatever out here. I just put it into the answer. I don't need to worry about it. Am I done with this problem? No. Not at all. Not even a little bit. What do I do? Simplify it. Divide the top and bottom by what? 5. 5. Top and bottom are divisible by 5. How do I know they're both divisible by 5? And in a 5 or a 0. Now, if you're not sure about divisibility rules, they're on the wall over there. Now, I'm sorry, unless you've got supervision from across the room, I can read the word divisibility. After that, I don't know what it says over there, okay? But I may get another one and just post it over here so you've got the divisibility rules on both sides. Honestly, the 3 divisibility rules that you should just know right now, 2, 5, and 10. Okay, everybody in here should know. How do you know if a number is divisible by 2? Jimmy James, how do you know if it's divisible by 2? Okay, not just a 0. It's even. Done. How do you know it's divisible by 5? Ends in a 5 or a 0. How do you know if it's divisible by 10? 0 in the tens place. Beautiful. End of the 0. Those are 3 rules that you should just know. It should just be second nature. 2, 5, and 10. Now, 3, 6, 8, 4, all of those, bonuses if you know them. Okay, 9, all of them. Worthless ones, 7 and 11. And if your grade school teachers taught you the divisibility rule of the numbers 7 and 11. You should thump them right in the forehead. But we're not done with 45 tenths, or hundredths, sorry. Both the top and the bottom divisible by 5. 45 divided by 5 is 9. 100 divided by 5 is 20, and you're done. 9/20ths. So, if it says, convert that decimal into a fraction, it will say in lowest terms, okay? That's all it means, is reduce it to lowest terms. You're done. That's all numbers 1, 2, 3, 4 deal with, or number 1, the 4 parts of number 1. Ding, number 2, what is the definition of a rational number? Now, if you're an individual that has not looked into your notes yet, can anybody give me a try on the definition of a rational number? What is a rational number? You're going to need to know this tomorrow in the test.
A rational number is a number you can turn into a fraction.
There you go. A rational number, for no better, no easier way of putting it, a rational number is any number that can be turned into, stay there, any number that can be turned into a fraction. We need to write this down if you, rational number can be turned into a fraction. Okay? Number 1, a rational number is any number that can be turned into a fraction. Period. Now, examples of that are everything that we really have worked on in here for the most part. Okay? A whole number can be turned into a fraction. 5 is 5/1. A decimal, 0.3, is 3/10. Okay? A repeating decimal, 0.2 repeating, is 2/9. I can turn that into a fraction, no problem. How about the square root of 16? What's the square root of 16? 4. Can I turn that into a fraction? 4/1. Yep, that's all still on the board there. Now, all of those are numbers that we can turn into a fraction. Repeating decimals, terminating decimals, whole numbers, and perfect squares. All good. What is the definition of an irrational? Say it louder.
Something that can't be turned into a fraction.
It's as easy as that. Something that cannot be turned into a fraction. Cannot be turned into a fraction. Cannot be turned into a fraction. Examples of that are any non-perfect square root. A non-perfect square root is an irrational number. Done deal. No thought process at all. If I get a square root that's not perfect, irrational. Okay? Can anybody give me another example of an irrational number? Tell me.
The square root of 49.
Square root of 40. Woo, be careful. Square root of 49 is a perfect square, isn't it? That would be a rational number because square root of 49 is 7, and I can turn 7 into a fraction, 7/1.
Oh, like pi.
Thank you. That is a huge one. Remember that. Pi is an irrational number because the decimal is like 3.14, blah, 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 on and on and on. Never repeating, never terminating. Never repeating, never terminating. Now those words right there are huge because if they give you, number 1, a decimal value like this, 5.73 ... that just means it goes on forever. And without any repeating line over the top of it, that means it doesn't repeat. That means it's a never ending, never repeating decimal. Never ending, never repeating. Irrational. So any of those examples up on the board right now, irrational. Non-perfect square root, pi and then a decimal that they give you that just goes on and on. Now, if I give you a repeating decimal, like if I wrote this, let me give you an example, see if you can answer. Here is my problem. What if I have negative 1.73524 repeating? Write that down in your notes, or on that sheet, or somewhere, and then tell me by writing the word, or the letter, R for rational, or I for irrational next to it. And see if you can get a freebie 2 points, because this is what it would be. Honestly, it'd be 3 points, because, 2 points. 2 points, because you have to tell me if it's rational or irrational. And then, on top of it, why is it rational or irrational? Put this in your notes. Don't just leave it blank, because this is going to be recorded, but I might not send it out to you guys, because you were live. You were here. You got to see me talk about this. So make sure you take these notes. Negative 1.73524 with the line over the top of the 73524. Is this rational or irrational? What do you think? Why rational so quickly? Done. Done, done, done. That's exactly right. I don't care about the negative sign. It means nothing to me. The key to this one is, it's a repeating decimal. And I know that a rational number is a repeating or terminating decimal. That's a good one. Because if it's a repeating decimal or a terminating decimal, I can turn it into a fraction, no problem. We know that. If it's a never repeating or never terminating, a non-repeating or never-ending decimal, that's irrational. But this one repeats. This one repeats, so I know it is a rational number. I'm letting you know that is a question on the test. I promise you, they're going to give you a number that may have a huge number and a repeating line, or a huge number and it doesn't repeat. And you've got to know, number one, is it rational or irrational? Number two, is it and why is it rational or irrational? Now, somebody had a good question about 0.27 repeating on the bottom of the page. What was the great question about 0.27 at the bottom of the page that you had? You weren't sure how to turn it into a fraction, right? Let's look at the directions. You've got to be very careful. If you get this type of question on the test, does it ask you to turn it into a fraction? No, it's not asking you to do that. It's just asking, is it rational or is it irrational, and why? So we haven't learned how to turn 2-digit repeating decimals into fractions yet. We will, but not till later. So that's a good question about that sucker. All you need to know is it R or is it I? Is it rational or is it irrational, and why? Okay, you ready? I'm just going to fly through. Number 3, the 0.7 blah, 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 blah. Is that rational or irrational? The first one in that number 3. Why is it irrational? It's a never-ending, never repeating, never terminating decimal. Done. Never ending, never repeating. Good. 5/9. Why is it rational? Because it is a fraction. They will put this on a test. They will give you a fraction, and they'll ask you, is it rational or irrational? It's rational because it's already a fraction. 4.87. Why rational? It is a decimal. But it is a terminating, it's a decimal that ends. It's an ending decimal. If it's terminating, I can write that sucker as a fraction, no problem. Square root of 34. Irrational. Why? It's an unperfect, it's not a perfect square, so you can't take the square root of it. 0.27 repeating. Rational. Because it's repeating decimal. Done. And then the last one, square root of 49. Perfect square, so it is rational. Okay? Backside of this we've already gone over. I'm going to let you guys loose and let you work on this. I'm going to stop this video and post this to everybody, so if we need to watch it, we can watch it. Honestly, I'm going to give you guys till 20 after when we start the second step. You can start working on, or continue working on this worksheet, You can start working on another class's homework. You can look at another class's stuff. I'll be just pacing around. I've got to post this. Anything that you want to go over before we stop the video for the other class?